This video is on systems of linear equations and it's on section Syle E from the textbook. In this section we're looking at the elimination method of solving simultaneous equations. And this is the second method that we've looked at. In the last video we looked at the substitution method. Now this method involves manipulating one or both equations so that when the final equations are added or subtracted, one of the variables is eliminated. Okay, and the equation's reduced to one equation of one variable. So we're reducing it to a linear equation again. The steps involved in solving a system of simultaneous equations using elimination method are: step 1, if necessary, multiply one or both equations by constants, and you're doing that so that the coefficients of one of the variables in the equations are opposites or equal. You want them to be opposites if you're going to be adding the equations, or equal if you're going to be subtracting. You will then add or subtract the two equations together, and that will eliminate one of the variables. You'll then solve. You'll then find the second variable by substituting the variable you just found into either equation, and finally you'll check your solution by substitution. So let's look at an example. Here we have solved the system of equations 2x minus y equals 8, 3x plus 2y equals 5 using the elimination method. So I write out my equation and number them 1 and 2. Now it said that I needed the coefficients of one of the variables to be the same. So my first equation, the coefficient of x is 2, and in my second equation it's 3, so they're not the same. I could make them both 6, and that would involve multiplying equation 1 by 3 and equation 2 by 2. Okay, but let's look at our y's. Here I have negative 1 out the front, and here I have positive 2. So it's quite easy to make the coefficient of the y both 2, and I only need to change one equation to do it. So what I'm going to do is I'm going to manipulate equation 1 by multiplying everything. Okay, if I multiply every term by the same thing, I'm actually not changing the equation. I'm not affecting the balance. So let's multiply equation 1 by 2. 2x times 2 is 4x. Negative y times 2 is negative 2y. And that's going to equal 8 times 2 is 16. And that will become equation 3. I now rewrite my equation 2. And they're the two equations we're going to look at. Now because these are opposites, you've got negative 2y and plus 2y, I'm going to go equation 3 plus equation 2. So 4x plus 3x is 7x, negative 2y plus 2y is 0, so I've now eliminated the y's. 16 plus 5 is 21. So I've got 7x equals 21. To get x on its own, I just divide both sides by 7. So I've now got x equals 3. To find y, I substitute x equals 3 into any of the equations. Okay, so 1, 2 or 3. I'm just going to substitute it into equation 1 and I'll get 2x minus y equals 8. So 2 times 3 minus y equals 8. 6 minus y equals 8. Take 6 from both sides. So now at negative y equals 2. So that means y has to be negative 2. Coming up here is I've run out of my room. If I was doing this on paper, I would keep going down the page. So the solution is x equals 3, y equals negative 2, or as an ordered pair, 3, negative 2. Okay, I can now check my solution just like I did before. So the check would be equation 1 was 2x minus y equals 8, left hand side is 2x minus y, which becomes 2 times x was 3 minus y is negative 2, so negative 2. So 6 minus minus becomes plus, and that's 8, which is the right hand side. So that's correct. The other equation, left hand side is 3x plus 2y, so that's 3 times 3 plus 2 times negative 2, which is 9 minus 4, which is 5. And that's equal to the right hand side, so that's also correct. Okay, so therefore we know that my solution is x is 3, y is negative 2. Let's look at another example. Here it says solve the system of equations 2x plus 3y equals 14, 4x minus 5y equals 17, again using the elimination method. So write out both equations. And label them. Now how can I make the coefficients the same? Okay, it's easier if we only have to change one equation. Sometimes you might need to multiply both, but in this one I can look at, I've got 2x and 4x, so if I go equation 1 times by 2, I'll end up with 4x in both of them. So 2x times 2 is 4x, 3y times 2 is 6y, 14 times 2 is 28. So that's my equation 3. And then I'm going to write my other equation underneath because it's easier to be able to see what's going on. Now because my coefficients are exactly the same, okay, I've got positive 4x, now I'm going to subtract my equations. I'm going to go 3 minus 2. 4x minus 4x is 0. 6y take negative 5y becomes 6y plus 5y, so that's 11y, and that equals 28 plus 17. Sorry, I'm subtracting, aren't I? 28 minus 17 is 11. So 11y equals 11, so divide by 11, divide by 11. So y becomes 1. Now I'm going to substitute y equals 1 into, again, I just do an equation 1. So I've got 2x plus 3y equals 14, 2x plus 3 times 1 equals 14, 2x plus 3 equals 14. Try and isolate, minus 3 from both sides, so 2x equals 11. Divide both sides by 2, so x equals 11 over 2, or 5.5. Okay, and now write out my solution. Solution is x equals 11 over 2, y equals 1, or as an ordered pair, 11 over 2, 1. In algebra we usually leave them as improper fractions. Again, I'm not going to go through the check, but you can check to make sure that is correct. What now? Well, you need to practice. If you're still not sure, you can listen to the video again, try and do the examples that I've done in the video by just pausing and giving them a go yourself. Then complete exercise Syle E1 from the textbook.